All right, welcome to Coach Taylor's class videos. Today is our 2.6 notes, and we're talking about application of reasonable domain and range. So application just simply means word problems, and we're going to do domain and range of word problems. So one real quick thing that we need to go over before we get to our word problems is we need to talk about the difference between independent variables and dependent variables. So a key word that I want you to think of as we go through independent variables is it is the cause. So when we think about independent and dependent, we're looking at cause and effect. The other thing I want you to understand about independent variables is there's about 3 or 4 different ways that we can represent independent variables. One is they are our x value. They are our domain because we know that domain is x. And then finally, it's going to be our input. So sometimes they're going to talk about you need to input a number in for x, and then what is your outcome or what do you get once you put it in. And so those are just some other names and some other terms that also mean independent variables. And now what I want to do is I want to talk about independent variables and what they look like in word problems. So typically in a word problem, an independent variable is going to be a noun, which means it's going to be candles. Oh, I cannot spell again today. Give me 2 seconds. So we're talking candles. We're talking tickets. We're talking months. We're talking hourly, so hours. But anything that is going to be our per, our each, or our every. And so that's going to be our independent variable when we're looking at word problems. So now let's look at dependent variables. So if my independent variables was my cause, then my dependent variables are going to be my effect. And if independent was x value, dependent is going to be our y value. If independent was domain, our dependent is going to be range. If independent was input, dependent is going to be output. And so what that means is when we're looking in word problems is our dependent variables is going to be if they bought 8 tickets, how much did they pay? If they went to the gym for 3 months, how much did it cost them? If they worked 70 hours, how much did they make? If they purchased 7 candles, how much money did they earn? And so when we look at dependent variables, they are always going to be our totals. So it's going to be the total cost, total earned, total paid, total salary. I think that's spelled wrong, but we're going to move on. And so dependent is our totals. Independent is the amount purchased or made or worked. So when we are looking at word problems, the first thing we need to do is we need to write a function. So a function is simply f of x equals 3x plus 2, or we know that f of x is the same thing as y, so y equals 3x plus 2. So in this case, we're looking for our x, our each, our every, our per, and we're also looking for the coefficient to go in front of it. We're trying to figure out what's the constant, if there is one, that's going to be our initial, our start, our one-time fee. And then finally, we're going to look for the total. If they don't tell us the total, we're going to decide that the total is going to be represented by the variable y. So the thing that's unique about domain and range word problems is we have to decide, is it continuous or is it discrete? And so the easiest way to decide this is to ask this question. Can I have half of the x variable? So I'm going to give you a couple examples and we're going to kind of go through this. So if we're looking at our example from independent variables, which is our x variable. So if x equals candles, does Walmart sell candles by the half or the whole only? If they only sell candles by the half, then candles are going to be discrete because no one's going to buy half of a candle because we just don't sell half of candles. If we're talking about hours, so if our x is hours worked, We have to ask ourselves, can you work half of an hour? Can you work a quarter of an hour? In almost every job that I'm aware of, you get paid based on the total time worked. And if that total time is 5.5 hours, they give you that 30 minutes of pay. And so that half tells us that it is going to be continuous. All right, let's look at another example. So let's say X equals tickets. So if you're going to the movie theater, or you're going to a game, or you're going anywhere where you need tickets, they never sell you half a movie ticket or half a ticket to a movie. They're not going to let you just watch the first half. You're going to buy a ticket for the whole thing. So that's going to be, again, discrete data. And so we real quickly have to remember the difference between discrete and continuous data. So discrete data, let's make that an A. Discrete data is a list of values. And when we list those values, we write it from least to greatest. An example would be, we would use our funky brackets, and 0 tickets bought, 1 ticket bought, 2 tickets bought, 3 tickets bought, 4 tickets bought, etc. And so that would be our example of discrete data, whereas our continuous data is a range of values. We use interval notation, and we write it like this: number less than or equal to y less than or equal to a number. So we're given that range. So once we know if our x is discrete or continuous, we then know how to write our domain and range. So let's look at our example problems. So a student is taking a test. There are 10 problems on the test. For each problem, so there's my each, that's my keyword. This is going to be my x variable. So for each problem, the student answers correctly. The student received 10 points. So the first thing I need to do is I need to write an equation. I do not know the score of the test, so I'm going to represent the total points or the score by y. And I know that my x or my each is each correct answer. And I know that each correct answer is worth 10 points. So we're going to go 10x. And then there is no initial, there is no beginning, there is no nothing else I need to add. So now we need to look at our independent variables. So we said earlier in the notes that our independent variables is our x. So if I'm looking at my x, if I'm looking at my per, each, or every, my each represents the number of correct answers. And now we need to look at our dependent variable. So our dependent is our y. And so if we're looking at our y in the equation, if a student gets 3 answers correct, then they get a 30. And so that y would be the total, or it would be the total score. So we could also think of it as grade that the student got for the test. So those are our independent and our dependent variables. So now we have to make a decision. So I know that this test that this problem is talking about is a multiple choice test, and there is no partial credit given. So if there is no partial credit given, I either get the whole answer correct or I get the whole answer wrong. There is no fraction. There is no 0.5s or 2.5s. So this is going to be discrete data. And so if I'm doing domain and range of discrete data, I need to list all values. So if I think about domain is going to be number of answers correct. Well, I know there are 10 problems on the test, and I know I need to write this from least to greatest. So I know students can get 0 problems right. That's very rare and almost never happens. They can get 1 problem right, 2 problems, 3, 4, 5, 6, 7, 8, 9. And because there's only 10 problems on the test, they cannot get more than 10 questions right. So when we're looking at range, what we're looking at is we're looking at the total score or the total grade. So what I'm going to do is I'm going to go look at the numbers that I just wrote down for domain. So if a student gets 0 questions right, I know that 10 times 0 is still 0. If a student gets 1 question right, I know that 10 times 1 is 10. If they get 2 questions right, 2 times 10 is 20. So I'm just going to keep on going down the line and list all the possible total scores of this test. That's supposed to be 100. And so I would list every 10th number. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, because those are all the possible scores a kid could get on a test. And so that's what discrete data, domain, and range looks like. So now let's look at our next question. Joe had a summer job that pays $7 an hour. So that's my per, that's each my every. And he worked between 15 and 35 hours each week. So again, we said an hour per each or every, so that's going to be my X. But I know I don't have a total. So if I don't have a total, I know that Y becomes my total. I know that each hour he works, he makes $7. And I know that hours represent X. And it doesn't say anything about initial, startup, or beginning fees or anything. So that's where I stop. So now we have to figure out what is the independent variable. And our independent variable we know is X. And we said our X is going to be hours. Next, we need to find our dependent variable. Our dependent variable is Y. And so Y is going to be here in the equation. So Y I know is going to be the total money made, or his salary for that week. So now we have to decide, is this discrete or is this continuous? So can Joe work 15 and a half hours? Can Joe work 23 and a half hours? And I know that answer is yes. So it is continuous data. And because it's continuous data, we need a range, or we need to use our interval notation. So if we're doing domain, I know that domain is my X value, and I know that my X value is hours. So the problem tells me that Joe works somewhere between 15 and 35 hours every week. So the least amount of hours he works is 15, but he could work anywhere between 15 and 35. So I'm going to go less than or equal to X, less than or equal to 35. So he's somewhere between these two numbers, and the equal to tells me it could be 15 or it could also be 35. So now when we're trying to find the range, we need to see what is the range of money Joe can make. So if Joe is going to work 15 hours, I need to take my equation, y equals 7x, and I need to plug 15 in for x, because we said domain is our x values. So I'm going to real quick do a little bit of mental math. So 7 times 5 is 35. 3 times 1 is 7 times 10. So the minimum amount that Joe can make if he only works 15 hours is going to be $105. And then I need to see what's the maximum that Joe can make. The maximum is if Joe works 35 hours. So y equals 7 times 35. So I take 35 times 7. 3 times 5, or 7 times 5 is 35. 7 times 3 is 21. And 21 plus 3 is 24. So less than or equal to y, less than or equal to $245 is the max that Joe could make in 1 week. And that is how we do domain and range of word problems.